Alright, in this video we are going to talk about creating scatter plots, and even more specifically we're going to talk about drawing a line of fit to match our situation. So if you take a look at this is what we worked on the other day with getting these scatter plots all set, and I want to draw your attention to a couple of things. First of all, graphing the data on the scatter plot, make sure you label the axes. So this is a year since 1995, since that's our X value, and the trees planted would be our Y value. I want to talk about the units that I use to go up by here. If you look at your X values here, they go from 1 to 9. So we usually like to start at 0 if we're going to do all positive numbers. That's why we've got the L graph, because they're all positive numbers. And if you go from 0 to about 9, if you went up by 1s, you'd get to like right about there. So going up by 1 should be fine. I labeled every other one because that way it gets the numbers don't start to kind of run together. And then if you look over on the left hand side at the y-axis, again all positive, and they go from about 0 again to about 360. The way I got I went up by here is I took the range of that, which is 360, and I divided it by 14 because there's 14 blocks. Alright, and when I divided that, I got about 25.7, I think, somewhere around there. And so 25 would be just not quite enough. The 360 wouldn't quite get on there. I don't like to go 26, 27 because I like to have nice whole units so that I can see kind of the values a little bit better. So I went up to 30s, and I said 30, 60, 90, 120, 150, 180. So basically I went by 30s, but I only labeled every other one so that I've got a little bit more room to put my values and they don't blend together and so forth. All right, so that's making the scatter plot. The next thing we did was find the mean or average of the X values and the mean or average of the Y values. All right, and that's the point that you really kind of want to make sure that your line of fit goes through. So what I'm going to do now is I'm going to take a ruler, and it helps if you have a clear ruler so you can kind of see a little bit of the points. Sometimes you can take your ruler and kind of set it up like this so that you can look at it and say, alright, well I've got 2 points below right now and I've got 2 above. You don't have to have an equal number of points on the top or on the bottom, but you want it to go somewhat through the middle of your data. So it's going to look something like this. And if I just slide that down just a little bit, my graph is going to look something like this. So then I just draw my line through. And if you notice, if you look at it, you know, we've got this one's a little bit above, a little bit below, a little bit below, pretty close, and a little bit above the line. So it's not going to be perfect, and not everybody's going to have the same exact line, because this is a line of fit. If we're trying to find the line of best fit, we'd have to use our calculators to do that, and it would be doing calculations that we don't even, we haven't quite got to and won't get to in Algebra 1. So if we're looking at this though, now we've got our line. Alright, so we drew a line in, and make sure your line goes through the coordinate from question D, and it does go through that coordinate or really close to it. If it's just off, it's not the end of the world, but you want it to be pretty close to it. The next thing you want to do is write the linear function to model the line you drew. Alright, so in order to write this function, I need to use 2 coordinates. I can see right here that it goes through 2, 0, and I'm going to make just a small little table up here at the top so that you can kind of see the values that I'm dealing with. So x and f of x, and it's going to be 2, 0. And then let's see, it also looks like it goes through this coordinate right here, which is 4, 90. So I can use these 2 coordinates, and I could find more if I wanted to along here, but I can use these 2 coordinates to get an average slope. Alright, and if we look here, my run is going to be 2, while my rise is 90. So my slope is rise over run. So 90 over 2, which is 45. So my slope is going to be around 45. If you had a slope of like, I don't know, like 40 or 50, you're not way off. But if your slope is, 10, you're going to be pretty far off on that. So you're going to want to revisit that. So if you look at your slope is 45, now I'm going to write my function, write the linear function to model this. I'm going to write f of x equals. Now, if I had a y-intercept right along here that I could see, I would put it in slope-intercept form. But since I don't, I'm going to use point-slope form. We talked about this the other day as well. And I'm going to put the 45 as my slope, parentheses, and then x. And then I can use any coordinate here that I want to. I'm going to use the 490. So I'm going to use x minus 4 and then plus 90. And I can put that in my calculator, and I can look to see how close these values are to it. Again, you're going to see they're going to be off a little bit. And then it talks about how is this data correlated. And this, if you look at it, it's got a positive slope. Right? It's not close to 0. It's going to be a positive correlation. And then use the model, the linear model, the date of the data to estimate the number of cottonwoods planted in 2006. Right? So now we're actually going to use this to make an estimate. And if we look at this in 2006, years since 1995, 2006 is going to be 11 years since 1995. So what we're going to do now is we're going to say f of 11 equals 45 times 11 minus 4 plus 90. And I can just put this in my calculator and get the value for this, or I could have put this function into my calculator with the x and then gone to the table to where x is 11. Alright, so let me do that calculation real quick. That is going to be 45 times 11 minus 4 and then plus 90, and that gives me 405. So that's a good estimation for how many plants will be planted in 2006. Now explain how this data could be useful to a farmer, to a scientist, to a botanist, or to a homeowner. All right, if you're thinking about trees planted, right? If you are running a greenhouse, I'll write that down. A greenhouse, or you are making trees. Knowing how many trees are needed in Oregon in the year 2016 might be helpful if this trend were to continue, because then you know how many that you need to plant, that you need to start, so that people can take them and they can plant them. So that would be one way that it might be helpful. It also might be helpful if the cottonwood plant, or the cottonwood tree is is really involved in allergies, like I'm sure most cottonwood trees and hybrids are. So knowing that there'll be more, and about how many they're going to be, and is that going to really increase the number of allergies that people have, and looking at that trend. So those are just a couple of ways that that this data could be useful. Right? So now your job is to go down to the one on the bottom and the one on the back and answer these same questions, drawing in your line of fit. You might want to check with the person next to you after you get your line of fit, after you get your function for it, and see that your slope is similar to theirs. Again, it doesn't have to be the same, but it should be similar, in the same ballpark. All right?